Okay. So let's talk a little bit about our clustering. So we have 4 main components in our clustering. The ECDB, which we talked about before, which is our clustering database. It is persisted. It runs on a consensus algorithm. It also uses Bezoar as its consensus algorithm. It's highly available, fault tolerant, and resilient to power failures. In each node, we have a clustering agent, which monitors the rest of the nodes and reports errors if it sees nodes not responding to it. Again, this is done using regular networking. And then we have the clustering officer. So the software for the clustering officer exists on each node, but is active only on one of them. The clustering officer decides the data path rate kind of decisions. We'll see in a minute which ones those are exactly. And it needs, we want to have only one of it because we don't want to have conflicting decisions. And the way we ensure that we have one of them is by election through the ECDB, which uses that compare and swap operation I described before. Basically, we try to become elected, and then the office, only one of the nodes will succeed because only one of them will have the previous key.
You said it uses standard networking. There's not a heartbeat network behind it?
No. Just regular.
Notice?
So we were designed to run on 10 gig Ethernet, but other than that, we're just sending packets over it. Again, this is the kind of things that if you want to run in the cloud, it's better not to assume anything about your hardware, because when you get to the cloud, your assumption might not hold. And then there is an additional service, which we call the ECS, the clustering service, which does the control rate kind of operations like add node, remove node, rebuild, rebalance, and so on, the operations that are not data path rate operations. So let's look how a failure looks like from this point of view. So we'll assume for this, in this example, that the left node failed, which had the active CO, the active officer running on it. So the first thing that will happen is we'll get a new CO elected. A new officer will be elected. And then it will start fencing the node. Now, fencing the node includes 2 operations. One is to tell the data layer not to accept any more transactions that include ownership of the left node. So either transactions that originated from the owner on the left node or transactions that it participated in. Once we know that the data layer prevents these transactions, we know that this node cannot affect our system anymore. And I remind you that we don't have power fencing or network fencing, so all of our fencing is done by software. So this is the barrier that we include in order to ensure that it can't come back and change the metadata afterwards. And the second part of phasing is to go to the orc and tell it this node failed, start initiating recovery of those files, and start enabling this fast path for recovery for user IOs. So it recovers the files in the background, and if there's a user IO, it will do a fast path recovery. And IOs can continue to run within about a second, 1.2, something like that. Now, IOs that are not for files that were owned by that node can continue. They won't even notice this. But IOs that are on files that were owned by that previous node will wait that amount of time and then can continue running.
Well, there is a timeout on the data read if the
yes,
data lives someplace.
So there is a timeout. The timeout, if I recall correctly, is 100 milliseconds today.
Okay.
And what will happen is, so there's two parts to a read. There's to select from which replica to read, and then once you selected, you have the timeout.
Right.
So the first IOs you'll select wrongly, and then you'll have to go by the timeout. But the next IOs, you'll see that queue is building up, and you'll not even choose it. So the percentage of IOs that will get that latency is very small. Okay, and then the last part is for the ECS, for the clustering service, to rebuild and rebalance the different services. So for the data layer, we have, for example, it was 3-way replication. Some of the 3-way replication copies are down, so we need to bring it back to 3-way replication. For the orc, it's the same thing. We might have had 5 nodes, and now we have only 4, so it continues working. There's no problem here, but we want to bring it back to 5 so we can support additional failures, and the same for ECDB. And then the last thing, we can replace the node, and it will be added to the system, rebalanced, and of course we can add nodes and remove nodes also without failures.
Well, just when you have a node failure, like that left node failed, and then the recovery happened to other nodes. Essentially, you're just making other nodes the owners, the copies becoming owners, right?
Yes.
Is that a permanent thing? So that's when that's done. When you bring a node back online, it's essentially like you're adding a new node.
So when you bring a node back online, you're adding a new node.
It's basically new. Okay.
However, if it gets the workload again, the ownership can transfer. Ownership is all in memory, right? So it's very cheap to transfer it. It's not moving data.
Right.
And if the node that failed, if you're talking about the data aspect of it, so if the node failed, when it comes back on, you can do increment and rebuild, and then you're just going to copy the differences that occurred during the time it was down.
And that's automatic.
Yes. I mean, bringing it up might require user operation, but the rest is automatic.
Well, from your report, right? Getting it back up to
Yes.
now. Yeah.